Okay guys, so I'm going to do an example of average rate versus insta rate. So the problem says, for each problem, find the average rate of change of the function over the given interval. And also, find the instant rate of change at the leftmost value. So what they want me to do is they want to find the average rate between 1 and 3 halves, or 1.5, or 1.5. And then they want me to find the instant rate at 1, which is the left point between the 2 points. Okay? So to find the average rate, first what you got to do is you're going to say, okay, if I want to find the average rate, then this must be A and this must be B. So let's go from 1 to about 1.5. Okay, that's the value it's going. So I want to find the average between 1 and 1.5. This is my function. So the skeleton is like 2 parentheses squared minus 2. So what's in my parentheses is what I'm going to plug in into my function. Okay? So to do that, to find the average rate of change, well, this is simply the basic slope of the function. Okay? And so you don't remember the slope. The slope is y2 minus y1 divided by x2 minus x1. Okay? Again, y2 is simply means f of b. y1 is simply means f of the a value. Okay? And then x2 would just be my b, and x1 would just be my a. And so really, I have a fancy name of the function value at b minus the function value at a divided by b minus a, just simply saying the output 2 minus output 1 divided by x input 2 minus x input 1. That's all it's saying. Okay? So to do that, we're going to say, okay, then that means I'm going to get f of b, which is 3 half, minus f of a, which is 1, all over 3 half minus 1. So I'm going to plug into my equation. Okay? So when I do that, I'm going to say, okay, let's plug in 3 halves. So if I plug in 3 halves, here's the work. I'm going to get 2 parentheses 3 halves squared minus 2. And you can do this on a calculator if you want. But when I do that, you clearly see that I'm going to get 3 halves squared. And so 3 halves squared is actually 3 squared, which is 9. 2 squared is 4. So this is really 2 times 9 over 4 minus 2. Okay? Well, what is 2 times 9 over 4? Well, that's 18 over 4, right? So 18 divided by 4, you're going to realize, oh, there's a 2 here. If I reduce, that'd be 9 halves. So 9 halves is like 4.5. 4.5 minus 2, and you're going to get 9 halves. 9 halves is 4.5 minus 2, which is 2.5. So here you're going to get 2.5 minus, when I plug in 1, okay, when I plug in 1 here, I'm going to get 2 times 1 squared minus 2. So where's 2 times 1? 1 squared is 1. 2 times 1 is 2. 2 minus 2 is 0. So f of 1 is actually 0. Okay? And then I'm going to get 3 half minus 1. Well, 3 half minus 1 is simply 1 half, or 0.5. So then your answer is 2.5 divided by 0.5. And when you do this in the calculator, you're going to get that the average rate between 1 and 3 half is equal to 5 unit per units. Units of distance per units of movement. So it's like meters per second, wherever it be. But since we don't have any unit here, we're just like unit per unit. Okay? That's called the average rate. All right, so before I show you how to calculate the average rate of change from 1 to 3 halves, or 1.5. Now I'm going to show you how to calculate the instantaneous rate of change at the leftmost value. So by leftmost value means this value right here. This is the leftmost value at 1. So basically what they're saying is, what is the instant rate of my function at x equals to 1? Okay? So you're not sure what this is. This is simply means I'm going to go start at 1, And now I'm not going to go to 1.5. I'm just going to go to 1 plus little tiny h. Okay? And if I do that and I take the slope and take the limit as h go to 0, I'll get very close in such a way that I'll know exactly what is my velocity at 1. Okay? So, notice here, this is A and B earlier. This is now your new A. This is now your new B. So if I take the limit as h go to 0 of my f of b, which is 1 plus h, minus f of a, which is 1, all over h, then I'll be able to find the instant rate at this particular function at exactly x equals 1. The moment I am at 1, what is my velocity? That's what it's asking. Okay? So to do that, I have to say, okay, here's my skeleton. This is my skeleton here. My skeleton, my function is 2 parentheses squared minus 2. So anytime I see x, I'm going to plug in 1 plus h. Every time I see x, I'm going to plug in 1. That's what f of 1 is. Means my function, I'm plugging 1, and then I'm going to function it. Or f it to get my output. I'm going to plug in 1 plus h, and I'm going to f it, and that'll give my output for the function at 1 plus h. That's what it means. Okay? Now, in case you don't know what h come from b minus a. So if I take 1 plus h minus 1, the 1 cancel out, I'm left with h. So b minus a really give me h. Okay? And that's always true anytime you want to find the instant rate. There's always an h in the bottom. Okay? So now let's figure out what's f plus 1. So I'm going to take this and I'm going to plug in here to my function. So wherever x is, you're going to plug in 1 plus h into your function. So when I do that, this is actually the limit as h go to 0 of 2, 1 plus h squared minus 2. Okay? This is the front minus the back. Take 1 and plug in here. So I'm going to get 2, 1 squared minus 2. And that's going to be all over h. Okay? So I'm going to ask myself, well, what is 1 plus h squared? So let's reduce that. So when I reduce that, 1 plus h squared is simply 1 plus h times 1 plus h. Two of them. Okay? So I'm going to do a little tiny Punnett square here. 1 plus h, 1 plus h, 1 times 1 is 1, 1 times h is 1h, 1 times h here is 1h, h times h is h squared, so if I combine like term, I'm going to get 1 plus 1h, give me 2h plus h squared. So this is really means I'm going to take the limit as h go to 0 of 2 parentheses 1 plus 2h plus h squared minus 2, that's in the front. And then I'm going to minus that, what's in the back. So here's the back. 1 squared is 1. 1 times 2 is 2. 2 minus 2 is 0 all over h. Okay? So now by distributive property, when I do that, I'm going to get the limit as h go to 0 of my particular function here. So I'm going to get 2 times 1 is 2. 2 times 2h is plus 4h. 2 times h squared is positive 2h squared. And then I'm going to minus 2 here. And that's going to be all over h. Well, what happened to the 2? Reduce again. So then this problem becomes the limit as h go to 0 of what's here? Well, do you see how they have h in common? I'm going to take out an h, and I'm left with 4 plus 2h all over h. Now the h reduce. So it's now become a removable function. So I'm going to say, well, I can't reduce it anymore. So I'm going to take the limit as h go to 0. So as h go to 0, this h here becomes 0. So what's 2 times 0? Well, this whole thing just becomes 0. So that tells me that as h go to 0, I'm going to get 4. So my instant rate 4. So this formula means that my instant rate, my slope of the instant rate, okay, is equal to 4 unit per unit. My instant rate is equal to 4 unit per unit. So if I compare to the one before, you can see that if I compare to the one before, here we go, my average rate is 5 units per unit. That means on average, if I go from 1 to 1.5, my average speed is actually much higher than my instant speed, because my instant is 4 unit per unit. Okay? So I'm going to give you an example of that. Let's say you're driving a car on the freeway. Okay? Now, if you go from, let's say, 60 miles to 70 miles, okay, then on average, you're traveling in the middle, which is 65 miles an hour, right? But the instant, anytime between 60 miles and 70 miles could be 61, 62, 63, 64, 65, 66, 67, 68. Any of those times you could have passed any of those speed limits. But on average, your speed limit is 65 miles an hour. Does that make sense? So that's kind of like saying, okay, on average, I travel 65 miles an hour, but at any weekend time, I could be lower than 65, or I could be higher than 65. Okay? So you look at here, my instant rate is 4 units per unit at exactly 1. Whereas here, my average rate between 1 and 1.5 is actually 5 units per unit. So the average rate is actually much higher than instant rate. Or sometimes the instant rate will be much higher than average rate, depends on the problem. Okay? Got that? So with this example, you review it, you should be able to do the rest of the practice problems to build your skills better. Okay? Apply this to your homework, to your classwork, that you're going to do it in class. All right?